Hey, what's going on, guys? We have this question right here. It's asking determine the normal force, shear force, and the moment at point C. So first of all, before I begin this question, let's mention the forces here. So since this one has two possible forces, so let's say this is By and this is Bx, and if this is Bx and this one going to have only one possible force, it's going to be vertical force. So it's going to be Ay, and the question is asking for normal force, shear force, and the moment at C. So this is where we're going to find. So in this case, we have two unknown in B and one unknown in Ay. So first of all, it's better to solve for Ay and find the value for Ay. So to find that, I can take moment around B to eliminate these two unknowns. So if I take that, let's see what happens. So if I take moment around B, it's going to be 0 in statics, and if I take total moment, if I take counterclockwise positive and solve for this one, I will get Ay is in 9 feet distance, so it's pulling this object clockwise, therefore it's going to be negative Ay times 9 feet. Then we have this, and this is 3 kilopascal, and the distance is 6 feet. So we know the this represents the equal forces, so we have to find the one force exactly in the middle. To calculate that, I can simply multiply by 3 by 6 feet. It's going to be 18 kilopounds exactly in the middle, 3 meter distance. So it's going to be 18 kilopounds in the middle. I can erase that to avoid confusion. So if I erase this, 18 kilopounds is going to be exactly in the middle. So this is 18 kilopounds, and that is pulling this object counterclockwise. Therefore it's going to be positive, and the distance is 3 feet, right? Here is 3 feet, and this is 9 plus 3 is going to be 12, and 18 kilopascal is pulling down, so positive 12 times 18, and that's the moment it's creating. And these are the only two moments we have, so this is going to be equal to 0. And if I solve for Ay, I will get 24 kilopascal, sorry, kilopounds. So if it this is my final answer for Ay. So now we have Ay. Now we can cut this part off and find this all the forces we need. So if I cut this part off, let's see. So I draw this part separately. So this is my C, and this is gonna be A in the middle. Not in the middle. This is 4.5 feet distance, and this is 6 feet, right? 6 feet, and we have 18 kilopounds acting in the middle of this. 18 kilopounds, and we have found Ay already. It's gonna act this side, and we had to find shear force, normal force, and moment. So let's say shear force acting this side is going to be Vc, and normal force at this side. So we can just assume the direction, and when we solve, if we get negative direction between our assumption is wrong, so we can correct it later. So let's assume this is the direction for now, and say solve for this one. So this is going to be Na, and I assume MC is this direction, and let's solve for this one. So first of all, let's begin with the horizontal forces. So sigma f of x is equal to 0 in statics, and if we take this direction positive and solve for this one, if you see, N is the only horizontal force we have, so therefore N is going to be 0 because there is nothing else to interact with it. So N is going to be 0, and we can solve summation of f of y is equal to 0. And if I take upper direction positive and solve for this one, I will get 18 kilopounds acting downside, so it's going to be negative 18 kilopounds, negative 18, and then and then we have AY acting upside, it's 24 kilopounds, we already found it, so it's going to be positive 24, and we have VC acting downside, so it's going to minus VC equal to 0. So this is going to be 24 minus 24 minus 8 is 6, negative 6, 20, for positive 6. Yeah, for VC is coming out as, so positive 6. If we go to the other side, it's going to be negative 6, and since VC is negative VC, so it's going to be positive 6, positive 6 kilopounds, yeah. So this is the answer for VC, and then the only thing we left is we had to find the moment around C. So if I find the moment around C, 0 in statics, and if I solve for this one, let's take counterclockwise positive, and if I do that, I will get, so I'm only I'm doing from this picture. So VC and this thing is going to be eliminated, and I'm taking MC in the clockwise direction, so it's going to be negative MC, and then we are not going to put VC, we are going to put AY. AY is going to be, AY is 24, right? So, and it's pushing this object upside, so it's going to be clockwise, so therefore it's going to be negative 24 times 4.5. Then we have 18 kilopascal pushing this object in the counterclockwise, and it's in 4.5 plus 3 is going to be 7.5. So 7 plus 7.5 times 80, that's it, so equal to 0. And if I solve for this one, MC comes out to be minus 27 kilopounds feet, feet. This means this movement is acting on clockwise, and our assumption is wrong, so we can correct, and we can put the direction as, oh, if we put negative, it automatically represents that it's acting in the clockwise, or you can write it at positive and mention the direction. So there are two ways to write this answer, so let's write in two ways. So this is acting in clockwise, 27 kilopounds feet, that's it. So I hope you guys like this video. See you next time.